Have you ever really thought about how we'd find aliens? I mean, for the longest time, the main plan was pretty simple. Just listen for a message. But what if we've been going about it all wrong? Today, we're diving into this really cool, kind of radical idea from a 1960 paper that totally flipped the search for ETs on its head. It suggests that maybe, just maybe, we shouldn't be listening for aliens, but looking for what they build. So let's just hop back in time to 1960. The whole field of SETI, that's the search for extraterrestrial intelligence, was basically brand new. And the big idea, the one everyone was excited about, came from a couple of physicists, Cocconi and Morrison. Their plan was pretty straightforward. Point our giant radio telescopes out into the cosmos and just listen. The hope was that some advanced civilization out there would be trying to get in touch. You know, it's a nice thought, right? But the whole thing rests on this one huge assumption, that aliens are actually trying to talk to us. And that's where physicist Freeman Dyson stepped in and asked a really simple but totally game-changing question. What if they're not? What if a super advanced civilization is just, too busy doing its own thing to send out a cosmic hello? And this, right here, is the genius of it. Dyson said, hey, let's stop trying to eavesdrop on alien phone calls, and instead, let's start looking for their construction projects. And we're not talking about, a new skyscraper. We're talking about massive, star-sized megastructures. Okay, so before we get to Dyson's big, wild idea, let's just take a quick look at the thinking he was challenging, that original search method based purely on listening. Right at the beginning of his paper, Dyson actually gives a nod to Cocconi and Morrison. He's like, yep, I see what you're doing, looking for radio signals, it's totally feasible, it's the main game in town. So he's not dismissing it or anything, he's just about to offer a fascinating alternative. And here's the pivot. Dyson suggested we should look for something that's totally unavoidable, something that any advanced civilization would be pumping out, whether they wanted us to find them or not. So Dyson's whole argument is built on this thing he calls energy metabolism. And it's pretty simple, really. Think about your laptop. It gets warm, right? Factories, data centers, our whole civilization, they all pump out waste heat. Dyson's point was that this is basically a law of technology. You cannot use huge amounts of energy without creating waste. And an alien civilization, no matter how advanced, they wouldn't be any different. And this little chart really shows you the massive difference. The old search was like looking for a tiny needle in a cosmic haystack. A specific, deliberate message sent our way. Dyson's idea was to stop looking for the needle and just look for the haystack itself, that huge, unmissable sign of industrial life, glowing in the form of waste heat. So the big question is, why on earth would a civilization produce so much waste heat that we could actually see it from light years away? Well, the answer comes down to two things: growth and energy. Dyson based his argument on something called Malthusian principles. The basic idea is that any successful species will just keep expanding until it's used up every last resource available. So he figured, once a civilization has mastered its own planet, its hunger for energy and living space isn't just going to stop. What's the next logical step? Go for the biggest resource in your neighborhood, your star. To give you some perspective, Dyson figured that back in 1960, all of humanity was using about 10 to the power of 20 ergs of energy per second. Now, that sounds like a huge number, and it is, but just keep that number in your mind for 1 second. Because this is the grand prize. The sun's total energy output is a mind-boggling 4 times 10 to the power of 33 ergs per second. That is a 13 trillion-fold increase over what we were using in 1960. So you can see, for a civilization that's always growing, capturing all of that becomes the ultimate logical goal. And this brings us to the most famous and, frankly, the most jaw-dropping part of Dyson's paper, his incredibly ambitious engineering proposal. I mean, it's one thing to say, let's go harness our star, but how would you actually do that? The scale is just insane. You can't just cover it in solar panels, so what's the grand solution here? And there it is, straight from the man himself. His vision wasn't some ring or a bunch of satellites. Nope. He was thinking of a complete, solid shell, an artificial world built to completely box in its star, capturing every single bit of its energy. This incredible idea is what we now call a Dyson Sphere. Dyson didn't just throw this idea out there. He actually did some rough math. He proposed you could take a giant planet, he used Jupiter as his example, and literally dismantle it. Then you'd use all that raw material to build a shell around your star, giving you a habitable surface area millions of times bigger than your home world. And this is the part that makes it so wild. He actually calculated that if you took all the mass of Jupiter and spread it out into a sphere twice as far from the sun as the Earth is, you'd end up with a shell that's about 2 to 3 meters thick. Just like that, this crazy science fiction idea suddenly had some real physics behind it. Okay, so if these unbelievable structures are actually out there, how in the world would we find one? This is where the whole thing becomes a real, testable scientific idea. Well, if you were looking in a normal, visible light that our eyes see, a Dyson sphere would be almost impossible to spot. I mean, it would completely block out its star, so it just looked like a dark patch of space where a star ought to be. It would be hiding in plain sight. But that's only half the picture. And here is the smoking gun. The sphere would absorb all that energy from the star, and the shell itself would heat up. Dyson figured it would be about room temperature, maybe 200 to 300 Kelvin. Well, basic physics says it has to radiate all that energy back out into space as waste heat. And the result? The sphere would be invisible to us, but in the infrared spectrum, it would shine like a star. It would be a giant artificial infrared sun. And you know, the best part is that Dyson gave us a clear plan. He pointed out we should be looking for these bright spots of infrared light, and luckily for us, Earth's atmosphere just happens to be transparent to those exact wavelengths, which means we could use the telescopes we already had right here on the ground. He basically turned a wild thought experiment into a practical to-do list for astronomers. So for more than 60 years now, we've been looking. We've scanned the skies with better and better telescopes, searching for those telltale infrared signatures. And so far, well, nothing definitive. And this leaves us with that huge, profound question at the very heart of the search for aliens, the Great Silence. Does it mean we really are alone? Or that civilizations like this are just incredibly rare? Or maybe, are we still just not looking in the right way? Dyson gave us a powerful new way to search for the answer. But for now, the mystery of the quiet universe remains.